Hi everybody. So hopefully today we were able to look through our slides from States of Matter Part 1 and also complete our Google form that was assigned on our Google Classroom. I did just want to take the time to look over some of the calculations that were in your notes, so I wanted to look at a few temperature conversions with you first. In your notes, you noticed that there were degrees Celsius, which I'm sure is something that we've heard of before, but there were also units of Kelvin. And Kelvin's going to measure the amount of kinetic energy our particles have. So we'll see both of these units as we move into our next chapter as well. So we want to make sure that we can convert between the two. So if we were asked to convert from 70 degrees Celsius to Kelvin, we'd want to use this equation that we have up here. We're trying to solve for K and we're given C. So all we have to plug in here is our 70 degrees Celsius plus 273. And if we add that up, that's going to give us our temperature in Kelvin, which would be 343 Kelvin. If we're looking at this on the other side, right, we're going to notice we are given Kelvin and we want to convert to degrees Celsius. So if we're given this situation, we're going to want to use the equation that's up here. For solving for degrees Celsius, we're given 153 Kelvin. We're going to have to subtract our 273K. And this will leave us with negative 120 degrees Celsius. Hopefully this makes sense. Again, if you have any questions, please feel free to email me or send a comment on Google Classroom, but I do want to look at one more conversion that you saw in your notes. So if we flip this over, we may have noticed that we were given these pressure conversions. We have 1 atmosphere, that's what ATM stands for. We have 760 millimeters of mercury, 30 inches of mercury, 14.7 psi, which stands for pounds per square inch, and 101.3 kilopascals. So all of these units will be used to measure pressure, and they're all equal to one another. So what we're going to do here is look at some conversions that maybe we'll be given. So for example, if we're given 41 inches of mercury and we're asked to convert this into millimeters of mercury, we're going to have to use some dimensional analysis using the conversions that were given to us here. So if we are told we have 41 inches of mercury and we want to convert this into millimeters of mercury, we know that 30 inches of mercury are going to be equal to 760 millimeters of mercury. So if I want to get rid of my units here, inches of mercury, I'm going to use this conversion factor here. 30 inches of mercury will go in our denominator. That factors out and leaves us with the 760 millimeters of mercury in our numerator. If we multiply 41 times 760, divide by 30 inches of mercury, we should find that we get 1038.67 millimeters of mercury. So it's just some simple dimensional analysis. So we'll try one more. If we're told we have 2.3 ATM and we want to convert this into PSI, okay, let's look up here at our conversion sheet. We know that 1 ATM is going to be equal to 14.7 PSI. So the units we want to get rid of are ATM. We can factor those out, and we're left with our 14.7 PSI in our numerator. Again, multiply the top, divide by the bottom. That should leave us with 33.81 PSI. Hope this helps. Let me know if you have any questions.